Imagine your ESP32 as a sensor in a smart greenhouse that not only measures temperature and humidity but also decides irrigation schedules based on live weather data from the internet. To do this, your ESP32 must talk to web services using HTTP and REST protocols. In this lesson, you learn how to send HTTP GET requests to fetch data from online APIs and HTTP POST requests to upload sensor readings to servers. You'll gain practical skills to integrate your ESP32 with cloud services, handle JSON payloads, and respond to real-world events dynamically. By the end, you'll be able to connect microcontrollers to the wider web ecosystem, turning simple devices into intelligent, responsive IoT nodes. HTTP is the standard protocol for transferring data over the web, and REST is a lightweight architectural style for building scalable web services. Think of REST APIs like vending machines. You request a snack with a button press, and a machine delivers it. For ESP32, a GET request is asking for data, like fetching current weather, while a POST request is submitting data, such as logging your greenhouse's sensor readings. REST's stateless design ensures each request is independent, which is perfect for microcontrollers with limited memory. Understanding these principles lets you build robust IoT systems that can fetch commands, report status, and interact with cloud dashboards efficiently. Always consider network latency, payload size, and retry logic in your designs for real-world reliability. Picture the ESP32 sending a GET request to an online API server. The server responds with JSON or text, which the ESP32 passes and acts upon. In the reverse direction, a POST request allows the ESP32 to push sensor data to a server and receive a status confirmation. This flow is crucial for real-time IoT applications, ensuring devices react dynamically to external data and report their state back to the cloud. Managing requests asynchronously prevents blocking critical tasks, and using structured JSON ensures interoperability with dashboards or analytics platforms. This fundamental pattern repeats in smart homes, industrial monitoring, and cloud-connected devices worldwide. To see HTTP in action, we'll use the ESP IDF framework to fetch data from a public API. The ESP32 connects to Wi-Fi, constructs a GET request, and prints the server's response to the serial monitor. The _HTTP_event_handler manages incoming data in chunks, avoiding memory overflow on constrained devices. This approach mirrors real-world IoT systems where devices continuously fetch updates from weather, stock, or analytics APIs. Understanding the event-driven design here is critical. It allows your ESP32 to multitask, fetching data while also handling local sensors or controls, making your project scalable and reliable. In this exercise, the ESP32 packages sensor readings in JSON and posts them to a server endpoint. You specify content type headers and handle server responses for success confirmation. This mirrors real IoT deployments like logging environmental data or device status to cloud dashboards. Properly handling status codes ensures your system can retry or alert on failed submissions. Using JSON provides a structured, widely compatible format for downstream analytics. This pattern, GET for fetching commands, POST for sending data, is foundational for cloud-connected IoT applications, from smart agriculture to industrial monitoring. Working with HTTP on ESP32 is straightforward, but common mistakes can break connectivity. Double-check URLs, endpoints, and API keys. An incorrect URL will silently fail. Avoid blocking calls. Use free RTOS tasks or event-driven handlers to maintain responsiveness. Parsing JSON manually can lead to errors. Use libraries like CJSON for structured handling. Wi-Fi dropouts are inevitable. Implement reconnection logic and log errors. Finally, be mindful of API rate limits to prevent throttling. From experience, always test with local mock servers first, then scale to public APIs. These practices ensure reliability, maintainability, and real-world readiness for production IoT systems. Now that you understand HTTP GET and POST, you can expand your projects. Fetch live weather data and trigger LEDs or relays based on thresholds. post sensor readings to cloud dashboards like Thingsboard or Firebase to visualize trends. Combine GET and POST in one ESP32 to receive remote commands while reporting device metrics. Finally, schedule periodic GET requests using free RTOS timers to implement automated monitoring. These exercises reinforce asynchronous handling, JSON parsing, and server interaction skills, preparing you to build robust IoT systems that interact dynamically with the cloud and respond intelligently to environmental data. In this lesson, you mastered HTTP GET and POST requests on ESP32 using ESP IDF. You explored RESTful design, JSON payload handling, and asynchronous event-driven programming. With these skills, your ESP32 can fetch external data, post sensor readings, and integrate with cloud platforms for intelligent, connected IoT solutions. Applying these methods, you can create smart environments, industrial monitoring systems, and interactive devices that respond dynamically to the world around them. These foundational skills make your IoT project scalable, maintainable, and ready for real-world deployment.